This is the video for section 4-1 on solving quadratic equations by graphing and factoring. Key vocabulary in this section is quadratic equation, zero of a function, root of an equation, binomial, trinomial. The essential question for this section is, how do you solve a quadratic equation by graphing and factoring? A zero of a function is a value of the input, which is your x, that makes the output, f of x, equal to 0. The zeros of a function are also known as the x-intercepts. Unlike linear functions, which have no more than one zero, quadratic equations can have two zeros, such as shown right here. You have one right here on the left, and you have another right here on the right. And if you notice that these zeros are symmetric about the axis of symmetry. First example, you have a graph shown, and it asks you what are the zeros of the graph. So you look at your x-axis here, and you find where does the graph cross the x-axis. If you notice, it crosses at 2, and it crosses at 4. So the zeros of the graph are x equals 2 and x equals 4. What other information can we get from the graph? Well, you should be able to find your vertex, your axis of symmetry, and you should also be able to see if there's a y-intercept on graphs that have it graphed. Now, some graphs may not have them graphed, but you always should look to see if you can actually see the y-intercept. On this graph, your vertex is your lowest point. So if you look, your lowest point is right here, and the coordinates for that are at 3, -1. The axis of symmetry is the line that runs through the vertex. And the equation of that would be x equals 3. Your y-intercept is where does it cross the y-axis, and if you notice, it crosses the y-axis right here at 8. So at 0, 8, it crosses the y-axis. If you're looking at the table of values, how would you know where the zeros are? Well, for example, if I was looking at the table of values for this graph, it would probably look something like this. When x is 0, the y is 8. When x was 1, y looks to be 3. At 2, 0, 3, -1, and at 4, 0. So by looking at your table of values, you could tell where your zeros are because they are the values at which the y value is 0. Let's look at another example. So the question again asked us, what are the zeros of this graph? Well, if you look at the graph, it never crosses the x-axis. So there are no real zeros. Since the graph never crosses the x-axis. And if you're looking at the table of values, how can you tell this? Well, the y value will never be 0. The solution to a quadratic equation of the form ax squared plus bx plus c equals 0 are called roots. The roots of an equation are the values of the variable that make the equation true. And you can find the roots of some quadratic equations by factoring and applying the zero product property. And just so we're clear on when you will hear the term zeros and when you will hear the term solutions or roots, when we're talking about the functions, typically they will use the term zeros or x-intercepts. When we're talking about solving the equations, we will talk about solutions or roots. But they're all the same thing. They're all essentially where does the graph cross the x-axis. Now, the zero product property says that for all numbers a and b, if the product of two quantities is equal to 0, then at least one of them has to be 0. So all this is saying is if you know that two numbers are 0, then either the first one is equal to 0, or the second one equals to 0, or they both equal 0. Now, because we will be factoring to find our solutions, our roots, our x-intercepts, we are going to go back and refresh on our special products. First one is the difference of squares. If you have a squared minus b squared, then that's just equal to a plus b times a minus b. And the perfect square trinomial, where if you notice the first term is a perfect square, the last term is a perfect square, and this middle term is twice the product of the two numbers when you take the square root. So like they got the a from the square root of a squared is a, so that number went there. And the square root of b squared is b, so that number went there. And then whatever sign is in front of your middle term is the sign that went in the middle of the factored. And a refresher of two vocabulary words is that quadratic expressions with two terms is called a binomial, and quadratic expressions with three terms is called a trinomial. There's an I in there. So let's do some examples with the solving by graphing, by factoring. So the first one says f of x equals x squared minus 4x minus 12. So I'm going to say that 0 equals x squared minus 4x minus 12. Then I'm going to factor this, however, whatever method you know how to factor. When you factor it, just a review of the square method, if you decide to use that method. X squared goes in the top box, your c value goes in the second box, multiply them, we get negative 12x squared. The box down at the bottom by itself is the middle term, so negative 4x. Two numbers that multiply to be negative 12 and add to be negative 4 would be negative 6x and positive 2x. A factor of negative 12 that's also a factor of negative 6 would be negative 6, which leaves us with x. A factor of negative 12 that when multiplied by negative 6 would give me 2, which leaves me with x. And then if we check it, x times x is x squared, 2 times negative 6 is negative 12, x times negative 6 is negative 6x, x times 2 is 2x. So that tells me that this factors to x minus 6. So we have 0 equals x minus 6 times x plus 2. And then according to the zero product property, it says that one or both of these has to equal 0. So I'm going to take x minus 6 and set it equal to 0, and x plus 2 and set that equal to 0. get x by itself here. The opposite of subtracting 6 is adding 6, so I end up with x equals 6. The opposite of adding 2 is subtracting 2, so I get x equals negative 2. And you're done. On B, it says f of x equals 3 times 3x squared plus 18x. If you notice, there's only 2 terms here. There's not 3. So I would look at this and ask myself, is there a greatest common factor between 3 and 18? And that answer is yes. So now I have 0 equals, pull out the greatest common factor, which is 3. But then there's also a greatest common factor between x squared and x. So I'm going to go ahead and factor out an x. Well, 3x times what is 3x squared, and that's x. 3x times what is 18x, and that's positive 6. Now we set each factor equal to 0, so we have that our first factor is 3x equals 0, and our second factor is x plus 6 equals 0. Well, opposite of multiplication is division. So if we divide by 3, 0 divided by anything is just 0. So we have x equals 0. Opposite of adding 6 would be to subtract 6 from both sides. So we get x equals negative 6. Part C. Because the directions say to find the zeros by factoring, you have to get this equal to 0 first. And I'm going to do whatever it takes to leave with a positive x squared. So that means instead of moving the 4x squared over, I'm going to move the 25 to the left side. So the opposite of adding 25 is subtracting 25. So that gives me 4x squared minus 25 equals 0. Well, then I notice that this is just the difference of squares. So the square root of 4x squared is 2x. And the square root of 25 is 5. And according to the difference of squares rule, one's a positive and one is a negative. Then I can set each factor equal to 0. Opposite of adding 5 is subtracting 5, so I have 2x equals negative 5. Opposite of multiplying by 2 is dividing by 2, so I get x equals negative 5 halves. On the other one, opposite of subtracting 5 is adding 5. Opposite of multiplying by 2 is dividing by 2. So I get positive 5 halves. On D, we have 18x squared equals 48x minus 32. So our first step is to get this equal to 0. Again, I want to keep the x squared positive, so instead of bringing the 18 to the right side, I'm going to bring everything to the right side to the left side. So I'm going to have 18x squared. Opposite of a positive 48 squared is, or 48x is going to be minus 48x. And the opposite of subtracting 32 would be adding 32. Next thing I'm going to do is, before I even try and factor this, is I'm going to check to see if there's a greatest common factor to make my life easier and make my numbers smaller. So the greatest common factor between 18, 48, and 32 would be a 2. So I'm going to go ahead and factor that out. That gives me 9x squared minus 24x plus 16. Well, then I notice that 9 is a perfect square, 16 is a perfect square, 3 times 4 is 12, and 24 is twice that, so that's just a perfect square trinomial. So that's going to factor to 2 times 3x minus 4 squared. So then I'm going to take each factor equal to 0. So the first one tells me that 2 equals 0. Well, we know this will never happen. So this is extraneous. Don't worry about it. 2 is never going to equal 0. But then we also have 3x minus 4 squared equals 0. So to solve for x, I'm going to take the square root of both sides. So that leaves me with 3x minus 4 equals 0. Opposite of subtracting is adding, so I have 3x equals 4. Opposite of multiplying is dividing, so I have that x equals 4/3. And that would be your only answer. Last one, f of x equals 6x squared plus 13x minus 5. So we have 0 equals 6x squared plus 13x minus 5. Factor this, so that's going to factor to 0 equals parentheses 3x minus 1 times 2x plus 5. Set each factor equal to 0, so 3x minus 1 equals 0, and 2x plus 5 equals 0. Add 1 to both sides, so 3x equals 1. Divide by 3, so I get x equals 1/3. Opposite of adding 5 is subtracting 5, so that gives me 2x equals negative 5. Opposite of multiplication is division, so I get x equals negative 5/2. Last example, we're kind of going backwards on it. It says, write the quadratic function in standard form with the zeros of -2 and 6. Okay, so if I know that the zeros are -2 and 6, then that tells me that when I solved, I had x equals -2 and I had x equals 6. Now, if you remember when we were solving before on the previous examples, we always started off with one of the sides being 0. So basically you want to move everything on the right side back over with the x so that this becomes 0. So the opposite of subtracting 2 would be to add 2. So really that tells us that x plus 2 equals 0. And with x equals 6, you want to move it to the other side. So that really tells me that we had x minus 6 equals 0. So now you know that your two factors was x plus 2 and x minus 6. But if you read the question, it doesn't say leave it in factored form. It wants it in standard form, which means you need to FOIL this out. So that gives me f of x equals x times x is x squared. X times -6 is -6x. 2 times x is positive 2x, and 2 times -6 is -12. And then last step is to collect like terms. So -6 and positive 2 make -4. And so there is your quadratic function in standard form.